Section 3.3 part 2, our next example goes back to the problem we did earlier in section 3.2, the one about the dining tables and the chairs. If you remember right, what we did is formulated the problem. So we defined X to be the number of tables we were producing and Y was the number of chairs we're producing. Our objective was to maximize, and the handout does say that, the profit at $45 per table and $20 per chair. And that was subject to the number of board feet, which we had, the number of labor hours that we had. So we did all of this in a previous section. Now we're going to come in and finish the problem. First step, now that we've got that all done, is to come in and actually graph it. To do that, we're going to need those intercepts. So to find the x-intercept, well, let's label things. So there's 1, there's 2. So the x-intercept, 3,200 divided by 40 would be 80. 0, and 3,200 divided by 16 is going to give me 200. Yeah, 200, 0, 200, which again gives me an idea how big my axes need to be. Over here, 520 divided by 3 comes out to be 520 divided by 3 is 80. I'm going to double check that. That feels goofy. So 520 divided by 3 is 173.3. So. And then 520 divided by 4 is 130. So 0, 130. So it is fairly large axes. We got to get up to 200. I'm going to count by tens. So the handout actually has a nice grid on it that you can use. So 10, 30, 40, 50, 70, 80, 90, 100, 100. 50, 150, and then I need 200 on the y-axis, so up to 100, and we're good, 173, 50, 60, 70. Yeah. Okay, 10, 20, 30, 40, 50. This is the long part of the whole thing. Okay, so for line 1, on the y-axis, we're up at 200, and on the x-axis, we're at 80, 6, 7, 8. So it goes like that. Testing the origin again is your test point. 0 is less than 3,200, so we're going to shade towards the origin. And that is line 1. Okay, line 2 cuts through at 173 on the x-axis. So here's 160, 170, 173. And on the y-axis, we're at 130. So 110, 20, 30. So it does that. If you test the origin, again, you're going to see that 0 is less than or equal to 520, so there's line 2. We know we're in the first quadrant, so we'll go ahead and tack on the x and y greater than or equal to 0, and there's our picture. It's a beautiful picture. Our region is sitting inside. It's, again, 4 sides. It's a quadrilateral. It's this 4-sided shape sitting in here. And we know that the profit, it's a maximum, has to occur at one of the corner points. And we have 4 of them. So we have this one sitting here. We know that one, that's the origin, that's the 0, 0. We have this one sitting here, which is B. And B was on line 2, and it was the y-intercept, which is 130. So by labeling everything, I can definitely pick my answers out pretty good. C, we don't know. We're going to have to go find C. But D, we do know down here. D was our x-intercept for line 1, and the x-intercept for line 1 was 80. So this is 80 comes here. Let's go find C. C is where lines 1 and 2 cross. That's where these two are crossing. So I'm going to multiply the second one by a -4 to get the 16s to cancel out. So equation 1 is fine the way it is. Notice that when I go solve this system, I take out the inequality and put in an equal sign. And we'll do -4 times equation 2. So that's giving me -12x minus 16y equals a negative, whatever 4 times 520 is, which is 2,080. The y's will cancel. 12 from 40 is 28x equals 3,200. Minus our 2,080 gives us 1,120. And we're going to divide by 28. That to be 40. You read this sigh of relief that it's a nice answer. So we need our y value for that point. We can plug it in anywhere. I'll go for the easier numbers to plug it into. We know 3x plus 4y equals 520, but x is now 40. So 3 times the 40 plus 4y equals the 520. Well, that's 120. 4y is going to be equal to 400, and y will be equal to 100. So that gives me point C out there in space. So if I do that, I know that C is at the point comma 40 for x, 100 for y, and it kind of looks right. I mean, again, you can't rely on the picture itself, but I can definitely rely on my algebra. Now that we found our 4 corner points, we're going to come in and plug it into our objective function. Again, I'll make a little table just to make it easier on myself. So I have point A, so here are my corners. So that was at 0, 0. B, which was at 0, 130. C, we just found it 40, 100. And D, which is at 80, 0. Okay, and what we're doing is objecting that. We're trying to maximize the profit as our objective function. So that's 45x plus 20. If you plug in 0, you're going to get no profit. Over here, 0 for the x, but you've got so 0 plus 20 times 130. That's going to be 26 with 2 zeros. So 2,600. For this one, we'll have 45 times the 40 plus 20 times the 100. And that's equal to whatever that comes out to be. I have them written down someplace. 40, 100, that was 3,800. And then finally, in the last spot, we'll have 45 times 80 plus 0. And that one comes out to be 3,600. And those are your profits. So once we've found what the profit is at each one of our corners on our feasible set, we just pick the maximum because that's our objective. So the maximum is sitting right here. And then I like a nice neat sentence. The homework puts the sentence in for you. You just have to fill in the blanks. So what we're going to do is we're going to produce 40. And you remember that X was the number of tables, 40 tables. And Y, which is 100, the number of chairs. For a maximum profit of 3,800. There it is. And there's your first full-blown everything we could do linear programming problem. Nice job.